Now the topic is defloculated suspension and flocculated suspension. What is the difference between defloculated suspension and flocculated suspension, and what are the rheological properties they will exhibit? What kind of rheological properties they will exhibit? This is about deflocculated and flocculated suspension. In deflocculated suspension, the particles are suspended very clearly. The particles are suspended. Particles are distributed uniformly. The particles are distributed uniformly. So when I will keep this system at rest upon the long time storage, what will happen means, always the large means more density particle will be at the base due to the gravitational force. At medium range, small particles are at top. So what will happen when I will keep the system upon the long time storage? First, there is a settling of this large particle at the base. See, large particle first. Actually, I need to write at the bottom, but due to less space, I have written on the top. See, first one is large. Large particle settle, then medium, then again medium, then very small particle. They will sit like one upon another. After some time, what will happen means, this particle will grow like this. At a certain point, the particles will fall down. Like this. And whatever the small particles, they will be occupy the space present between the two large particles. Small particles will accumulate in the space present between the two large particles, leads to the formation of strong cake. Strong cake means hard cake. Means here the interaction between the two particles are like this. Strong hard cake will be formed. Once the hard cake will be formed, if you shake the system, this particle again not at all distributed like this. If even though how much time you can shake, the particles not at all distributed like this. Not uniformly distributed. The particles will not at all distribute uniformly. So what is the advantage of this one? Advantage of deflocculated suspension is more suspendability. Means if you shake and you can keep the system for more time, means this particle will suspend more. But at a particular time, upon long time storage, what will happen means, the particles will settle at the bottom. After some time, the small particles will fall between the space present between the two particles. Then what will happen? Leads to the formation of hard cake. Advantage is more suspendability. Means more time the particles will suspend in the system. What is the disadvantage? Formation of hard cake, which is unable to redisperse. Even though if you shake, the particles are not at all distributed like this. So this is disadvantage. How can we prevent the disadvantage? Advantage is needed. Disadvantage means formation of hard cake. How can we prevent the hard cake formation? Means just by adding the flocculating agent. Adding the flocculating agent. This is just a symbol for flocculating agent. Just by adding the flocculating agent, you can prevent the formation of hard cake. So what is the rheology? What kind of rheology this will exhibit means, deflocculated suspension having more than 50% of concentration, exhibit what kind of dilatant flow. This flow we can call as a dilatant rheology. Rheology means dilatant. Dilatant rheology this will exhibit. dilatant rheology. What kind of rheology? Dilatant rheology exhibited by defloculated. See, defloculated dilatant rheological property. See, what is the dilatant behavior means? This is a solution. You can consider this is a solution having this much. See, the surface of water is this much. Here the surface of water is there. So these are the particles are distributed. Each particles are surrounded by sufficient amount of vehicle. Each particle is surrounded by sufficient amount of vehicle. So when I will shake the system, when I will shake this defloculated system, the particles, when you will shake this system like this, the particles come upside. The particles will come upside, and whatever the solvent also present, the solvent that is also come upside. See, solvent coming upside, particles also coming upside. When this particle move from this position to this position, from here to here, then there is a formation of a little gap. Means solvent immediately cannot cover that space. Solvent immediately cannot cover the space. Hence there is a formation of oil bubbles. Means oil is not oil. Air bubbles. See, air bubbles are there. Air bubbles are there. Solvent volume. See, volume is increased. See, volume is this much here. Here the volume is increased. Okay. Next, insufficient vehicles. Vehicle is fully sufficient, means each particle are surrounded by water. Here insufficient. See, this part only surrounded by vehicle. This remaining part is surrounded by air. Hence we can call as the insufficient vehicle is there. So viscosity, relatively less viscosity. This viscosity is high. Relatively means compared to this, the relatively high viscosity. Relatively high viscosity. So this is the concept of dilatant behavior in case of defloculated suspension. When you will shake the system, this will exhibit defloculated suspension. Initially it is solid, it is gel. Gel means just nothing but increased viscosity. When the viscosity increases, the pourability of suspension is reduced. See, when you will apply, shear means just shaking. Shear means shaking here. Initially it is solid form. When you will apply the shear means shaking. Shear nothing but shaking. Then the system converted into the gel form. Conversion of salt to gel we can call it as a dilatant. Conversion of salt to gel we can call it as a dilatant behavior. So now another is floculated suspension. Another topic is floculated suspension. So particle size 0.5 to 10 microns, more than 10 to 50 microns particle size. So see here the particles are flocculated. See the particles, one particles are there. Here the particles are flocculation means aggregation like this. This we can call as a floccule or coagule. Coagule or floccule. These floccules are formed by the presence of flocculating agent. These floccules are formed due to the floccules are nothing but these particles aggregate. Floccules are formed by due to the presence of flocculating agent. These are the flocculating agents. So when you will keep this system, water also there. Here water also there. When you will keep the system at rest or upon the storage, what will happen means the particles are immediately settled at bottom. The particles are immediately settled at bottom due to the weight. See, one particle is there here. Here 3 particles are there. Whenever the weight is increases, gravitational force immediately act on this particle. They readily settle. This particle will readily settle at the bottom compared to the particles in the deflocculated suspension. Upon the storage, the particles, the floccules are flocculated suspension immediately get deposited, means formation of sediment due to the gravitational force. This particle immediately settle at the bottom. But the formation of loose sediment means, see, between the particles, attraction is small. Here between the particles, strong attraction, solid line, broken line, loose sediment is formed. Here. So how can we prevent? Means how can we prevent this? Advantage is formation of loose sediment. Advantage of this suspension is formation of loose sediment. Whenever the loose sediment is formed, means easily redispersible. This is advantage. Whenever the loose sediment, if we can shake the system, all the particles will be distributed uniformly. All the particles will be distributed uniformly. Easily redispersible due to the presence of loose sediment. That is advantage. What is the disadvantage? Means less suspendability. Means the particle not at all suspended for more time into the system. The particles, the floccules, not at all suspended more time in the system. They will immediately settle compared to defloculated. So I need to prevent the immediate settling of the floccules. Immediate settling of the floccules that can be prevented by adding the structured vehicle. Structured vehicle means nothing but hydrophilic polymers here. Structured vehicle nothing but hydrophilic polymer. So these are the structured vehicle. So this I have written. This is the beaker wall. This side white color chalk piece is beaker wall. This inside colored chalk piece is structured vehicle. See, all the floccules are separated. So this floccule immediately not settle. Due to the presence of structured vehicle. This also due to the presence of structured vehicle, they will not immediately settle. The immediate formation of sediment can be prevented by adding structured vehicle, or the structured vehicle we can call as a suspending agent. So this is about flocculated suspension. And what is the rheology? Means it will exhibit pseudoplastic or shear thinning or thixotropy. Pseudoplastic behavior or shear thinning system or thixotropy. Flocculated suspension exhibit thixotropy. How means, see, due to the presence of this structured vehicle or suspending agent, this will exhibit pseudoplastic form. How means, see, initially it is gel form. Means initial stage, whatever it is there, we can call as the equilibrium state. The initial state, it is gel form. Here the initial stage, equilibrium state is solid form. Here equilibrium state is gel form. Gel form is due to the presence of entangles, means between the particles. So between the polymers there is an entanglement, attachment. This attachment we can call as an entangle. This attachment between the particles we can call as an entangle. Due to the presence of that entangle, this will act as a gel. Due to the presence of entangle, the polymers acts as a gel form. But when you will apply the shear, means shaking, upon shaking, when you will shake the system like this, this whatever the entangles are there, whatever the entangles are there, they will broke, and they will orient. All the polymers will orient in the direction of application of shear. Means in the direction of application of shear means. So this is the water bottle. You can consider this is water bottle. I have taken the water bottle and I have shaken. So you can consider this is water bottle. I have taken. This is having this kind of gel form. Means all the polymers are entangled in this. When I will turn this and I will shake this, what happens? All the polymers present, whatever the polymers, all the polymers present, the entangle present in that system, they will orient like this. When you will apply shear means like this, in the direction of shear, means this direction. I have shaken the bottle like this, all the polymers will entangle, means will arrange like this. in the direction of shear. All the particles, see, all the particles will arrange, all the particles, sorry, not all the particles, all the polymers will arrange in the direction of application of shear. I have applied shear like this, horizontally I have applied shear, so all the particles will orient in the direction of horizontal direction. If I will apply the shear vertical, all the particles, sorry, not all the polymers will orient like vertical. I have applied like this horizontally, all the polymers will entangle. See, definitely broken down of entangle. Entangle will broke and leads to formation of single polymers. Polymers like this, the polymers are there, they will single like this. Then we can call it a sol form. This is gel form, this is sol form. Pseudoplastic, shear thinning, thixotropy. This is about the rheology. Pseudoplastic behavior exhibited by flocculated suspension. Deflocculated dilatant behavior. Deflocculated dilatant behavior exhibited by deflocculated suspension.